In this video, we will give a short introduction on text summarization. I will first talk about the relevance of the topic text summarization. Then I will talk about two general types and give an example of both types. Then Miel will talk about different techniques to use in text summarization and how we can evaluate the summaries that come out of these summarizers. We will also talk about the different applications and potential challenges and future work of text summarization. So why is text summarization relevant? Text summarization can be very valuable to us because we can extract valuable insights from large blocks of unstructured data text. This will save us time and effort because we do not have to read the whole text manually. Text summarization is also becoming more and more relevant since the digital content is also growing continuously. Text summarization also has many applications, such as news summarizers or document summarizers, for example. So the main goal, as I already said, is to save time and effort of the people reading blocks of text. And the different techniques which are used to do text summarization, such as NLP, for example, are also becoming more and more popular and sophisticated. So there are two main types of text summarization, which is extractive text summarization and abstractive text summarization. The main difference between the two is that extractive is an algorithmic approach and abstractive is a more human approach. So I will first give an example of extractive text summarization. So as an input text, we have here a text which is from the course of Big Data Science, which is from the introductory lecture. So using an extractive text summarizer, we will summarize this text. We did this in Python using the NLTK library. And what we basically did is we tokenized the text. So we tokenized it in sentences and words. Then we count the frequency of each word in the text. And based on this frequency, we can give every sentence a score. Then we can select the top n sentences, which will then appear in the summary. And if we take a look at the summary, every sentence in the summary also will appear in the original text. So if you take a look at the original text again, we can see that every sentence which is highlighted here is actually appearing as well in the summary, which means that extractive text summarization will literally extract sentences from the original text and will not make it up on his own. Whereas the other approach, the abstractive text summarization, if we apply this one to the same input text, we will get a shorter summary. And we made this example using the Hugging Face Transformers library, which basically contains already trained language models to generate text. So using this library, we can generate this summary. And if we take a look at the input text again, we see that some parts of sentences are omitted or replaced by other words, such as summarize, for example, which is replaced by outline on the previous dia.
I will now give an overview of the most prominent methods for text summarization: frequency-based, graph-based, and machine learning-based algorithms. For both frequency-based and graph-based algorithms, the main objective is to select only the most relevant sentences. All of the words in the document are given some weight, and these are combined within each sentence to get a score, and then only the sentences with the highest scores are maintained. For frequency-based methods, these weights are defined by some metric of frequency. The first one being relative frequency, which is simply the frequency of that word in the document divided by the total amount of words in that document. This metric is only useful when stop words are removed, because otherwise words like the will get very high weights. A better metric might be TF-IDF, term frequency inverse document frequency, which adds a factor which depends on the bigger set of documents. Words that are present in many documents will get a lower weight. For example, if the word the occurs in all of the documents, the TF-IDF of the becomes 0. And this way, stop words don't necessarily need to be removed, which is good because it might not be easy to create a good list of stop words. These methods are very simple, but don't look at connections between sentences, and thus redundant sentences can be included in the results. And because no new words or sentences are created, these methods are not suited for abstractive summarization. The basic idea of graph-based methods is the same, but the weights are calculated in a different way. First, a graph is generated from the document, where the nodes are words and the arcs are some link between the words. A very simple example is shown here, where first the stop words are removed, and then pairwise connections are made between the remaining words. Then a PageRank-like algorithm is used to determine the weights. PageRank is the first algorithm that Google used to determine the importance of web pages. And the idea is that the amount of arcs that end in a node determine its weight. So in this example, there's two arcs ending in boy and cake, meaning these two would have the highest weight. These methods are again very simple, although maybe not as simple as frequency-based methods. And because of the arcs between words, which are possibly in different sentences, redundant information can be removed. But because no new words or sentences are created, this method is again not suited for abstractive summarization. Then we have machine learning-based methods, which are currently the newest and most accurate methods for text summarization. The idea is just like any other machine learning approach, that a model is trained on a large set of training samples, and then the model itself can be selected out of a wide variety of structures. Machine learning methods are capable of creating new words and thus suited for abstractive summarization. However, they might be hard to train due to the high complexity and require a lot of data, and the model can act as a black box and therefore not be explainable. Now, it's not hard to see why text summarization can be useful in a wide range of fields. Just in day-to-day life, having the ability to quickly grasp the contents of a large text might be very useful. For example, in search engines, quick previews of pages are useful for quickly finding the most relevant one. The same applies for news and other media. Probably most of us have used models like ChatGPT to quickly read up on certain topics for courses, or to boil down large text into a couple of sentences. Within a business environment, being able to quickly assess the content of, for example, a long email can improve efficiency. And during research, sifting through a large number of papers can be time-consuming. By being able to quickly scan through the contents of many papers, researchers can work more quickly. The graph methods can also be used to find important related papers to quickly get a grasp of the entire research field.
In order to develop and improve different summarization methods, we need a way to evaluate how close our summarization is to capturing the essence of the original text. We can have humans evaluate the summarizations, but this comes with several problems, such as taking a long time, a lot of work, and not being feasible at a large scale. Because of these issues, some automatic solutions were developed. One of these being the Roeyen score. First, a few humans will write a summarization of some text, while a summarization method also tries to summarize that same text. The Roeyen score then tries to determine the similarity between the summaries by checking for similar words and structures. If the computer summarization is similar to the human summary, it will have a decent quality. The advantage of this is that after the humans wrote their summaries, they can be reused to test multiple iterations of that summarization method. This solution is not perfect, and there are several other methods, each with their own flaws.
There are still some important challenges within this field. For example, evaluating the performance of text summarization solutions is not trivial, since there is not a single best solution. There is also a need for standardized tests. And if models are not accurate, ethical concerns might rise about spreading misinformation. But there are also some interesting fields to dive into in the future, like creating models trained specifically for certain fields. For example, Find, which is an AI search engine created with developers in mind specifically. and increasing the robustness of machine learning-based methods and ensuring the explainability of their results.